Hello, and we are going to look at another heat problem today. Um, this problem reads, if 36,500 joules of heat energy were put into a 4,218.5 gram of a lead sample, and you have your specific heat capacity for lead, it's given here, 0.13 joules grams degrees Celsius, how much would the temperature change? Okay, now, same as the problems that we've done in some of my previous videos, we will write down our formula that we're going to use to solve this problem. Oops, let's go here. Let's try that. Sorry about that. And here, okay, let's try it now. So we will write down our formula. There we go, that's better. And it looks like this, MC delta T. Then what I get my students to do, and I certainly recommend it, I write down our variables, and we identify the values and plug them into the variables that we know, and we'll be left with an unknown. So again, 36,500 joules. Which one of these variables is measured in joules? And hopefully you would know that it is Q. Your students would know, my students hopefully would know that it's Q. So we would write in 36,500 joules of heat were put into a 4,218.5 gram lead sample. What variable is measured in grams? And we know that that is mass, so we plug in 4,218.5 grams. This is the one that the students find the easiest to identify because it's got the craziest unit. Look at this, joules grams degrees Celsius. So we plug this in here for C. That's our constant. So it's 0.13 joules over grams degrees Celsius. And here's the question, how much would the temperature change? And of course delta T is our temperature change, so there we have our good old unknown variable looking for delta T. Okay, so we will now substitute in these values into our problem, into our variables. So we rewrite. I tell my students, step 1, write down the formula. Step 2, write down what you know. Step 3, substitute your values. Okay, so let's keep on cruising here. So Q, we fill in 36,500 joules. Our mass is 4,218.5 grams. We have our constant 0.13 joules grams degrees Celsius, and our delta T, which is our unknown. Okay, so nothing here to solve on this side of our equal sign. So we will look over here. So we're going to multiply 4,218.5 times 0.13 and do this up here. We end up with 548.405. Units are important because we want to make sure when we end up solving for our x, we have something left that's expressed in degrees Celsius. So this all has to fit and make sense. Our grams cancel, and look, we're left with something that looks like this: joules over joules over degrees Celsius, and we take our x down, and let's have a look here. Yeah, we can solve for x here now. We've isolated all our variables and combined all our terms and divide through here. 548.405 Again, carry your unit, and we're going to do the same thing over here. 548.405 joules degrees Celsius. Of course, all of this, well, joules, that whole unit, and that whole unit, they cancel. And we're going to isolate our x, which is what we want. And let's look over here. Before we start solving this part here, we can cancel our joules and look at what we're left with. Well, degrees Celsius, that's the guy we're looking for, degrees Celsius. And when you divide 548 and change into 36,500, you end up with 66.5566. And when I go back up here, let's have a look. How many significant digits do we have here? There's no decimal there. If there was a decimal there, then these would all be considered significant. There isn't, so we would say there's 3 here. Easy one. They're all significant, all non-zeros. Over here, these 2, so we would have 2. So our answer has to be equivalent to the same as the least number of significant digits in our problem, so that means 2. So we start, there's 1, there's 2, so we're going to round to the 6, which means we look at the 5, and this is an even number. So in this instance, a lot of times students will assume, oh, it's 5, we round up. What I have my students do, I'll just show you this over here, 66.5, if we were going to round this 5 here is right in the middle in terms of the numbers that we round. 1, 2, 3, 4, 5, 6, 7, 8, 9. And to keep all things equal, the way that we do this, so that we're not rounding up more than not, if the number that you're looking at, only when it's a 5, is an even number, then it stays the same. So we would leave this at 66, using our proper number of significant digits, degrees Celsius. Now let's go back over here. If this was 67.5, and again we were going to round so that our answer would have 2 significant digits. This is the unit, the ones place that we're looking at. Of course, we look to the next place, and it's 5. Magic number, right? 1, 2, 3, 4. That's easy. It stays. 6, 7, 8, 9. It gets bumped. This one here is 5, and I have my students look and say, okay, look, this is an odd number, so we bump if it's odd, so that would become 68. So when it's odd and you're looking at the place and it's a 5, if it's odd, you round up. If it's even, you leave it the same, so it would stay at whatever the even digit was, 4, 6, 2, whatever the case may be. Okay, and that is our answer, 66 degrees Celsius. That is our x, which is our delta T. So let's go back and answer the question. If 36,500 joules of heat energy were put into 4,218.5 grams of a lead sample, how much would the temperature change? The temperature would go up 66 degrees Celsius. Okay, thank you for staying along and have a great day. Hope this helped.